We have already discussed question 1 and 2 of question paper 22970 in chemistry of the examination series October-November 2024, and let's discuss the next questions here. So let's continue with the question 3 now. So here is question 3, which says nitrogen and phosphorus are elements in group 15 of the periodic table. So nitrogen and phosphorus are the elements of the same group, that is group 15. Now what's the question? A is nitrogen is found in the inorganic compounds such as nitrogen oxides as given here, nitrates and nitric acid. Now identify one natural and one man-made occurrence of the nitrogen oxides in the atmosphere. Now what is the natural source from which we can get the nitrogen oxides? And that's the natural lightning which happens during the rainy days. So you can say lightnings or storm, you can also say. And what is the man-made source from which the nitrogen oxides are made? Now that is the internal combustion of fuels in the motor vehicles or in engines, you can write. So this is the answer we'll write. Now question 2 is write an equation to describe the role of NO2 in direct formation of acid rain. Now this NO2, that is nitrogen dioxide, is released in the atmosphere. It reacts with the water to form the acid rain. Now let's write the equation for that. Now when NO2, that is nitrogen dioxide, reacts with water, it also reacts with the oxygen which is present in the air to form nitric acid, that is NOHNO3. That's how it forms acid rain. When nitric acid is formed in the atmosphere and falls down along with the rain, that's called the acid rain. Now we need to balance this equation where hydrogen, oxygen, nitrogen, we are going to balance it, and that is the balance which you're going to make, that is 4 and 4. And now hydrogen required, that is the water requires 2. Now that's the balanced equation. Now the next sub question is peroxyacetyl nitrate, that's which is known as in short PAN, PAN, is a component of photochemical smog. Now that's photochemical smog, that's the chemical or you can say compound present in photochemical smog. Now describe how PAN forms from NO2. Now the main thing is that the nitrogen dioxide is reacting with the unburnt hydrocarbons which are produced by again the burning of fuels. So nitrogen dioxide reacts with the unburnt hydrocarbons to produce PAN, that is PAN, to produce PAN, that is peroxyacetyl nitrate. Now that's the how the photochemical smog is produced. Now fourth question is nitric acid reacts with the basic oxides to form the nitrates. Write an equation for the reaction of nitric acid with calcium oxide. Now we know nitric acid is HNO3 that reacts with the calcium oxide, that is CaO. Now this is an acid base reaction which produces the salt. Now I always teach my students that how is the salt formed. The hydrogen of the acid is displaced or replaced by the metals. So calcium nitrate is formed. Now calcium nitrate have the formula CaNO3 twice, and along with the salt, when an acid and base reacts, we always get water. Now to balance this, we need to add 2 here to get the balance of the whole equation. Now you can see the equation is balanced. So reaction of acid and base gives salt and water. Now the fifth question is describe what is seen when the solid calcium nitrate is heated strongly. Now when calcium nitrate is heated strongly, now let me write an equation here. Calcium nitrate is heated strongly, it's going to decompose into calcium oxide, nitrogen dioxide and oxygen. Now remember, I'm not writing a balanced equation here because it is unbalanced, but if these are the decomposition products, then we have calcium oxide, which is again in white solid. So here the white solid remains white solid, but NO2 and oxygen is produced. Now oxygen is colorless, but nitrogen dioxide is in red brown gas. So what should be the observation is the nitrogen dioxide is produced, which is seen as red brown gas, or you can say red brown fumes are seen. Okay, yes, that B part. Now B part is a common test for nitrate is a reaction with sodium hydroxide and aluminium, and the equation 1 shows the reaction. So here is a reaction of a nitrate, any nitrate compound with aluminium and sodium hydroxide and water to give ammonia and aluminium hydroxide. Now deduce the oxidation state of nitrogen in NO3, that is nitrate. Now if I show you the calculation, then in place of the oxidation state of nitrogen, I'm writing X plus the oxidation state of oxygen is always -2, but now O3 are present, that is 3 oxygen are present, so multiply by 3 equal to the overall charge, that is -1. Now if you work out, then it's going to turn out to be +5 the value of X. So value of X is +5, so the oxidation state of nitrogen is +5. Now identify the species that is oxidized in equation 1. Now there are two methods to find out that any element which has gained oxygen or that element whose oxidation state is increased. Now here we can see that aluminium has gained oxygen by getting aluminium hydroxide, or you can say element has the oxidation state of 0 here, because in elemental form all the elements have an oxidation state of 0, but here we can say that it is a +3 oxidation state. Now if it is +3, you can say that the oxidation state has increased from 0 to +3. So aluminium is the species which has been oxidized, so aluminium is the answer. Now ammonia is a basic gas. Describe how ammonia is able to act as a base. Now the only definition of a base is that ammonia accepts hydrogen ion, and that's how it acts as a base. Okay, so any species which accepts hydrogen ion is a base. Now let's go ahead. Here suggest the shape of aluminium hydroxide ion, that is AlOH4. Now we know that aluminium have 3 electrons in the outer shell. It's all shared with the hydroxide ion, so no lone pair is left. In fact, aluminium is surrounded by 4 hydroxide ions. So if with no lone pair, 4 species surrounded by a central atom, then the only shape which is possible is tetrahedral. So tetrahedral is going to be the shape of any species which is surrounded by 4 atoms or groups without lone pair. So this is how we get an answer. Now here is a question. It says figure 3.1 shows a sketch of some ionization energies of phosphorus. Okay, yes, we have first to 10th ionization energies. First 2 are given. Here are the first 2, and we are also given the species from 7 to 10, and the remaining are missing. Okay, construct an equation to represent the third ionization energy of phosphorus. Now third ionization energy means third electron is removed out. If third electron is removed out, it's going to be P3 plus. Now if it's removed, after removing, if phosphorus is forming 3 plus ion, the starting should be 2 plus ion, and we have to write the gaseous state for both the species, and that's how we're going to represent the third ionization energy of phosphorus. Now the second part is complete the graph in figure 3.1 to show the third to 6th ionization energy of phosphorus. Now we should understand that phosphorus is in group 5. So if it is in group 5, there should be a stable increase in the ionization energy of phosphorus till 5th, and then there should be a jump. So here if we have the energy in line, let's draw one more point for 3rd, 4th and 5th in line, which is increasing, and then there should be a jump to show the 6th ionization energy. So let's line out this. Okay, so here are the successive ionization energies. I'll draw a line which is increasing in steady way, then a jump, and then the remaining electrons from 6 to 10 in successive ionization energy, again increasing steadily or gradually. So this is how we are going to plot the graph for successive ionization energies of phosphorus. Okay, let me explain again. I have shown a gradual increase till 5th ionization energy of phosphorus because it is in group 5. So there are 5 electrons in the outer shell of phosphorus which are removed gradually, and then the 6th electron is removed from the next shell which is closer to nucleus, so it will require higher energy, and so there is a jump. Okay, so here we go. The D part, it says complete table 3.1 to show the properties of nitrogen and phosphorus in their standard states. Now nitrogen is gas in its standard state and phosphorus is a solid in its standard state. Now electrical conductivity of both is a non-metal, so it's going to be poor. Okay, type of bonding. Now nitrogen is an covalent bonding molecule where N triple bond N exists as N2 molecule. So let's write covalent here. Now phosphorus also is a non-metal which has a covalent bond between its molecules. So if both of them are having a covalent molecule, then the type of structure is simple structure for both because none of it is forming a giant covalent structure. So this is how we complete the table. Now the E part is a form of solid nitrogen has a lattice structure similar to solid iodine. Okay, identify the type of lattice structure of solid nitrogen. Now we know that the iodine and nitrogen both exist as I2 or N2, that is diatomic molecules. Now if they are having diatomic molecules and they're forming solid, if the molecules are brought together, still it is not going to form a giant structure. So it's just going to form a simple molecular structure, So this is how the lattice structure is going to be. Now F is at a very high temperature, phosphorus can form P2 molecules, that is with a triple bond in between. Now describe the formation of the P triple bond in the terms of orbital overlap. Okay, if we talk about the orbital overlap in P which has a triple bond altogether, then what should be the overlapping of the orbital kind or type? Now the simple thing where even nitrogen have a triple bond, so how are they formed? Now here we know that they are the P group elements, that is they have their outer shell electrons are occupied by P orbitals. So if the triple bond is formed, then one of the bond is sigma bond. You can say sigma bond because that is formed by linear overlap of P orbitals, Now whenever there is a double bond or a triple bond, one of it is at least a sigma bond. Even if there are single bonds, then those single bonds are sigma bonds. But if it has double and triple bond, only one is sigma and the remaining are pi bonds. So here we have written one of the bond is sigma bond which is formed by the linear overlap of P orbitals, and the next the two bonds, the remaining two bonds are pi bonds which are formed by sideways overlap of p orbitals. So that's how the triple bond are formed, and that's what you're going to write in the 2-mark questions. So description of sigma and pi bond formation, that's it. Now the second part is the bond energy of p triple bond p is 485 kilojoules per mole, and the bond energy of n triple bond is 944 kilojoules per mole. Compare the reactivity of p2 and n2. Explain your answer. Now if we know that the bond energy of P is less and bond energy of nitrogen molecules are more, then obviously phosphorus, that is P2, is more reactive. P2 is more reactive as it is easier to break the P triple bond P as it has less bond energy. Simple and straight as that. Or you can write the reverse ways, that is N2 is less reactive because its bond energy is higher and difficult to break the N triple bond, and that's how you can describe. Okay, here is question 4 where it says bromoalkanes are used widely in industries, although there is an increasing concern about their environmental impacts. Figure 4.1 shows a reaction scheme involving 1,2-dibromoethane. Now here is ethene, which is reacting with bromine to form 1,2-dibromoethane. Now that is again for the reacting with reaction 2 and 3 given. Now let's see what are the next questions here. Okay, complete figure 4.2 to show the mechanism or the formation of 1,2-dibromoethane in reaction 1. And here we have to show the mechanism including charges, dipoles, lone pairs of electrons and curly arrows as appropriate. So let's start understanding. Here are the double bond. Double bond has a high electron cloud which is negative. So it's going to attract a positive part of the bromine. So this is how we are going to show the partial charges. The bromine which is closer to the double bond should get a partial positive charge, and the bromine away from the molecule should be partial negative. Now this electron cloud is going to attract the partial positive bromine and is going to form the bond. So here we make the structure, that is CH2 here. Another carbon with again H2, but the bromine gets bonded on one of the carbon. Now because of that, the carbon here gets a full positive charge, that is an intermediate carbocation is formed. Now here is the remaining bromine ion which is a negative. So bromine ion should be shown as a negative with a lone pair, and show a curly arrow from negative to positive to show the bonding, and here is the final compound form. So this is how you're going to show all the curly arrows with full and partial charges. Here you can say there are partial charges in this molecule. You can see that there are full charges of positive and negative. So this is how you're going to show the mechanism. Okay, question B is enthalpy change of the reaction 1, that is reaction this is minus 90.0 kilojoules per mole. Enthalpy change of formation of ethene, that is this one, is plus 52.2 kilojoules per mole. Calculate the enthalpy change of formation of 1,2-dibromoethane. Now energy change of the whole cycle, if we are going to form, then we need to show the elements at the bottom. If I make the Hess cycle, so this is how I'm going to form. So this is the enthalpy change of the formation which we want to calculate. Here it's given minus 90.0, and this enthalpy change of formation of ethene, that is delta HF of ethene, this formation is given as plus 52.2. Now we can know that this one is the direct, and this route which I'm drawing now is an indirect route. Now direct route is the addition of two indirect routes which you're going to find. So delta HF, which we are going to find, is the addition of the remaining two enthalpies, that is enthalpy change of formation of ethene plus enthalpy change of formation of reaction 1, which I am writing here, reaction 1. So if we add directly, it's going to be 52.2 plus minus 90.0, and so we have the answer as minus 37.8 kilojoules per mole. So minus 37.8 kilojoules per mole. Now the unit is given here. If it's not given, we need to write it, but yes, it's given here, so we don't need to worry. Part C. Now the part C is complete figure 4.1. Here it says draw the structure of compound A and name the compound B. Now figure 4.1 is something here. Figure 4.1 is here, where we need to draw the structure of compound A and write the name of compound B. Now if it's reacting with aqueous NaOH, now this is an halogenoalkane. 1,2-dibromoethene is an halogenoalkane which reacts with aqueous NaOH. Then a substitution reaction occurs where the bromine is replaced or substituted by the OH group. So the structure of the compound should be OH here and OH here, that is both the bromine is replaced or substituted by the hydroxyl group. Okay, the next part, name of B. Now what's the name of B? Here you can see there are two carbon, so there is CH2 double bond CH, and then there is a bromine bonded to the second carbon. So if there are two carbon, then it's going to be ethene, and ethene is bonded with one bromine, so we can say it is bromoethene. Bromoethene is the name of the compound B. Fine, let's go ahead, see what's the next question. Okay, says draw the structure of one repeat unit of polymer C in the box. Now what is polymer C? Yes, now this is formed by the compound B, which is bromoethane, and forms a polymer C, and we need to draw only one repeat unit. Now we need to understand that if there are CH2, CH, okay, so no hydrogen here and one bromine here. Now if it's going to form a polymer, then this double bond is removed, and that's going to form an extended bond on both sides. So this is how we are going to draw. Replace the double bond by the extended bonds on both the carbons, and the remaining hydrogen remains as such. So here is hydrogen, and the second carbon we have one bromine atom. So this is how it's going to form a polymer, and this is the one repeat unit of polymer C. Now the third part is in reaction 5, compound B reacts with an excess of NaOH dissolved in ethanol. The products are HBr, H2O, that is hydrogen bromide water, and an unsaturated hydrocarbon D. Now let's understand that the B compound is written here already, that is bromoethene. Now here I am drawing the structure again. Bromoethene is here, and that undergoes an elimination reaction. Remember, NaOH dissolved in ethanol is going to make an elimination reaction. Now what is elimination reaction? Something out has to be eliminated. So the hydrogen and bromine will be removed out when ethanol in NaOH, NaOH in ethanol is going to react. So that's how it goes to form the hydrogen bromide, because that's eliminated out. So if this is eliminated out, then what is the product remaining? Now the bond which is broken by both the carbon, that will turn into one more bond, that is now it's going to form ethyne. So identify the compound D, that is CH triple bond CH it should be, or you can name it also as ethyne. Ethyne is going to form with CH triple bond CH. Let's see what's the next question. Okay, compound D, compound E is only isomer of 1,2-dibromoethane. Now alkaline hydrolysis of E gives compound F. So E is here, which is the isomer of 1,2-dibromoethane, and F is the compound formed on hydrolysis of this compound. Fine. Identify the type of isomerism shown by E and 1,2-dibromoethane. Now 1,2-dibromoethane and E, what's the difference? In 1,2-dibromoethane, the bromine is in each carbon. So here was the bromine. Now in this E, both the bromine are on the same carbon, and so that's called the positional isomers, because the position of the you can say functional group or the element has been changed. Only the position is changed. Let's see what's the next part. It says name the homologous series that F belongs to. Now here we can say that there is C, H and O present, so that is an aldehyde homologous series to which the F compound belongs. Third part is complete table 4.1 to state what is observed when F reacts with the reagents listed. Now as we have already found out that F is an aldehyde, that is simple aldehyde with 2 carbons. So 2 carbon is what? Ethanol. Now ethanol is going to react with 2,4-dinitrophenyl hydrogen, that is 2,4-DNPH. Now any carbonyl group when reacts with 2,4-DNPH, it shows red precipitates. So aldehyde or ketone, both are going to show the red precipitates. Now tolerance reagent. With the tolerance reagent, all the aldehyde are showing the silver mirror test. Okay, so silver mirror is observed with tolerance reagent and with alkaline iodine. Now alkaline iodine either reacts with the methyl ketone, that is CH3CH or CH3CO, or it reacts with the C and OH. So hydroxyl group on the second position of the carbon. So if any of this compound is present, it's going to react with the alkaline iodine to form the yellow precipitates of the triiodomethane. So yellow precipitates are observed with alkaline iodine when we have this compound present with us. Fine. Let's see what's the next question. Okay, compound. Okay, question E is compound F reacts with reagent G to form compound H. Okay, here is the reaction. Now infrared spectrum of H is shown in figure 4.3. So here is the infrared spectrum also shown. Okay, fine. Let's see. Here we have a broad peak at about 3100, crossing 3000 a little. Then we have one sharp peak at 1700, and we have another peak at 1300. That's what we can say. Yes. So here is the table also given, and it's written H also shows a molecular ion peak at M/E ratio of 60 in its mass spectrum. Now use the information in E, figure 4.3 and table 4.2 to deduce the structure of H. Explain your answer fully. Now let's understand figure 4.3 and table 4.2. So this is table 4.3, 4.2 and figure 4.3. As we have already known that we have peak at all these you can say wave numbers, then how can we deduce it and to find out the structure? Now crossing 3000, a broad peak we can make out it should be a carboxyl group which is here, right? It's not crossing 3300, it's just around 3000. So a carboxyl group of OH should be present. Now we had another peak at about 1700. 1700 we can say here is one more in the same range, and that is carbonyl C double bond O. Now we have carboxyl, hydroxyl and C double bond O. That's for sure that we have got carboxylic group from both this And yes, we have one more peak at 1300 which shows a presence of CO bond also, and we have, yes, definitely CO bond present for the carboxylic acid. Okay, so carboxylic acid is for sure present in compound H, that is F is oxidized to form H to form carboxylic acid. So the structure of S, we know we have 2 carbon, so carboxylic acid is formed, and so this is the structure we can draw for the compound H. Or we can draw a skeletal structure simple as 2 carbon with double bond O and OH. O should be here. Yes, this is how we are going to draw the structure in the skeletal form or full display form as shown. Now let's explain all this. So explanation is that a broad peak at 3000 per centimeter shows the presence of carboxyl OH group. Okay, then a peak at one more peak we have at 1700, so a peak at 1700 per centimeter shows the presence of C double bond O group. Okay, and another peak or the absorption, you can write anything, peak or absorption at 1300 per centimeter shows the presence of C single bond O group, and so we know it's a carboxylic acid, and yes, that's why a carboxylic acid is formed. Now suggest the role of reagent G. Now G is the reagent which change F from to H. Okay, so what is G? G should be an oxidizing agent, which changes an aldehyde group to carboxylic acid, adding an oxygen to it. So here we end with the 2 questions, that is question 3 and question 4, and I hope my explanations are very clear. And here we finishes with the question paper 2 of winter series of examination of AS levels. So here we ended a winter 24 question paper 2.